So I'm going to be talking about something a little different, I guess, coming from a different perspective than most of the sessions here. We're a software company. Actually, we build software platforms. So we're going to be coming from the space of building modern applications and how our technology is a very different way of building applications themselves so that they become semantic, so they become mineable. So just to introduce some of the concepts that we're going to be talking about. So basically, traditionally computing has been all about an operating system, processing code, and converting it into common instructions that our CPUs can understand, right? That's why you have one CPU in your phone or in your PC and you can run lots of different applications. Originally, that wasn't the case. There used to be separate electronics that people used to build for every single application until the microprocessor was created. But if you have a look at what most traditional applications are these days, only about 10% of the code is written to do calculations, and about 90% of the code is written to describe interactions with things. So yesterday I came back from the US. I had booked a flight to come back. I went on a site, I think it was Expedia, and I booked a flight. That wasn't really calculation, that was me interacting, finding an airline, finding a flight at the right time, right budget, lands at the right time so I could be here. What we find is that writing code to do interaction in things is actually extremely primitive, and it's actually really the worst form of trying to describe interaction. What we should really be doing is using graphs to describe interaction. And how do we know this? Because even a 2-year-old child, I've got 2 young children, when you ask them how do they see the world and how they interact with the world, they're doing everything through graphs. They're doing them, you know, you're my mum, you're my dad, these are my friends. I'm going with my friends to this play date, we're going to be down at the pool, we're going to swim. Like everything they talk about in terms of interactions and things, they're describing using a graph. Yet, we don't actually write software using graphs. We write software doing calculations. So the equivalent analogy is a 2-year-old child can quite easily put 2 balls in a container and actually understand what they've done. But they have no capacity to describe using Newton's equations what has actually happened. Yet that's what we do in code. We basically describe equations which are far more complex and far more unnatural than simply describing what we want to accomplish. So using our technology, we're able to go and rather than using code to describe 90% of the application, we actually describe things and the interactions with things using a graph. And so we've built a set of technology which is semantic computing, and we provide the world's first native semantic operating system, which actually allows us to compute a graph in real time and actually allow us to create interactions that are being generated whilst people are interacting. And instead of having, therefore, low-level procedures that are calculation-based, the low levels of our stack actually use operations that are related to graphs. 4 basic operations: creating, attaching, updating, and detaching. And we find that just with those operations, we're able to massively simplify code, eliminating 90% of the code that's written in a traditional application. So how does this blend in with what you guys are talking about largely here? Well, the way you describe in our system is using schemas. So objects that define things, all your thoughts on taxonomies and ontologies and predicates and everything all come in this. Basically 6 classes of objects in sets of graph nodes, events which indicate that something has just happened, an aesthetic which describes how I want to perceive something, styling, visual, heuristics which are rules that give me a probability of something happening, artifacts. These can be products, contacts, all the things that people are going to interact with, as well as symbolic things such as images or videos that might have to do. Schema, well, that's the basis upon which you create everything else. And actions, which is what I'm actually doing to change the world around me. Now, if I have those 6 plus the relationships between them, I can then go and take fairly complex enterprise systems. This happens to be the project I'll be talking about at the table, which is a wealth management portal being built by an American financial services organization on our platform, which involves custodians. These are the parties that hold your money, where you do your trading. if you guys know TD Ameritrade or these sorts of entities. The umbrella organizations that do the compliance to make sure no one's going to steal your money in the investments. The financial advisors themselves that are helping you manage your portfolios. The money managers, economists basically, that are telling you what's happening in the market. Right through down to the final customer whose money is being invested. We have a big set of portal infrastructure here that's being built as a set of applications. And the entire lot is being built on our stack using those 6 basic building blocks, and basically applications are being generated out of this runtime. The end result is we reduce about 90% of all infrastructure implementation. So on our platform, you never go to an AWS or a Microsoft Azure or anything like that. We reduce about 60% of software development. There is essentially no back-end development, as you would know. There's actually a lot less development in general. We reduce cost and time to market. It's a UX and business-led approach, and you get assets out of this versus code. So if you're interested, come by a table and hear about our Semantic OS and how we're using it to solve human problems versus calculations. Thanks.